going to talk about how to build your own functions, the syntax for it, and variations on it. So first of all, as I said, you already know about functions because we've been using them for objects like string objects and lists, and we've also been using built-in functions. Can you look at these 6 and answer these 3 questions? What arguments do they take? What do they return? Are they methods or built-in functions? Jot your answers down. Tell your neighbor if you feel confident. What arguments do they take, if any? Some of them don't take any arguments, so the answer is none. What's an argument? Thing that goes inside the parentheses. Thing that you pass in. What do they return? Sometimes they return nothing, or they return none. Sometimes they return a value. Are they methods or built-in functions? What's the quick way to tell that?
Dot notation.
Yeah, the dot notation. Okay, so I'm going to stop you wherever you are. Number 1. First of all, number 1, what's the function involved in this line of code? Function or method?
Method is capitalized.
It's a method, and the method is capitalized. What arguments does it take?
None.
It doesn't take any arguments. So, but you still have to put those parentheses because that's how Python works. What does it return?
Capitalized string.
The capitalized version of whatever you do, the object that you do the capitalization on. That's a method, and method is just a special word for a function when it is associated with an object. Number 2. What do we got there?
Method.
It's a method, and what is the method? Append. And what argument does it take? In this case, it's the number 5. But in general, what do you put in the parentheses there?
Any object.
Yeah, whatever it is that you want to add to the list. What does it return?
Doesn't return anything.
Yeah, it returns none, actually. It returns the built-in constant none. So what does it do if it doesn't return anything?
It just changes the list.
It changes the list, right. And specifically, Samantha?
It appends number 5 to the end.
Yeah, it appends number 5 to the end of the list. Number 3. What arguments does it take?
None.
None. What does it return?
Okay. A sorted list.
It, if I said x equals mylist.sort, am I going to get a sorted list in x? No, I'm going to get none in x. It again returns none. It's an in-place method that returns none, but it does the operation of sorting the list out. What about number 4?
The built-in function.
And so what's a built-in function?
Range.
Range is a built-in function. And what arguments does it take?
A min and
2
max.
integers.
Yeah, and 2 integers here. Min and max you're specifying here, or you can just do 1, and then you're specifying the upper bound. Or you can do 3, and you're specifying the start, the end, and the increment. Did we answer all our questions? What does it return? Yeah, it returns a Python list of numbers. So number 5 is on 2 lines, unfortunately, but it's supposed to be on 1 line.
ArcPy method.
It's an ArcPy method, yes. Get count is an ArcPy method, and the whole signature of it is get count management. What do you pass in here in general?
A file.
Some data file that has records that it can count, that it can handle counting.
But you pass a string that's the path name? I mean the file name?
This is actually the string name of the file. That's right. What does it return?
Result.
A result object. Number 6.
Method.
What's a method? Join is a method. Whose method is it? What kind of object? It's a string method. Here we're doing string literal.join. And what argument does it take? The name of this is a hint.
Oh,
A Python list. What does it do to the list? What does it return?
a string.
It returns a string with, can you describe the string?
The elements in the list separated by the semicolon.
Yeah, so it returns a string which has the string elements in the list joined together with a semicolon in between each of them. So if this were, say, lion.join ABC, you get A lion, B lion, C. Can you tell me another string method that you often use a string literal in front of the dot for? You use it pretty frequently, use it on your exam?
Format.
Yeah, format. If you think about it, that's a string literal dot format, and then some things in parentheses, whatever arguments you want to pass into the format. Those are some functions that we know about already. We don't know what's going on inside of those, how it's been implemented exactly, but there are chunks of code somewhere that they're called. How do you define a function in your own code? You can just use the def keyword, the name of the function. When you select a function name, keep in mind that the same rules as apply to other variable names apply to function names. Don't start the function name with a number. You can include an underscore in the name, and the name can include numbers, but no other special characters can be included. Avoid built-in object names like sum, range, format, file, list, and so forth. And when possible, when you name your function, use imperative verbs. For example, translate Y, rotate polygon, divide screen, not Y translator, not rotating polygon, not divided screen. And then parentheses. Now there may or may not be something inside the parentheses. We'll get to that in a minute. And then a colon. And after the colon, indentation. It's an indented block of code because it's defining a function. All of the stuff that's indented after the def statement is part of the function. You're remembering that if you do triple quotes, you're allowed to end the line without putting the triple quotation at the end of the line. You always want to put a statement at the very beginning that describes what the function does. And the convention is that you use triple quotes so that in case you need to expand that statement, called docstring, you can have it multiple lines and it won't matter. What is this function doing? Print every 5 years between 1980 and 2005. It creates a list of numbers. The range function returns a list of numbers, which we hold in the years variable. And then we do what? We just look through them and print each one of them. The output from this function will be this. This line of code down here is the line that actually calls the function. You define the function, and then you can call it later on in the code. This is one case where the order of your code matters because you have to have the function definition somewhere above the place where you call the function. Just like we would say range 111, we can say print years now because we've defined what that function is. And when we call that, and not before then, but when we call that, it'll print this output. When it's being defined, it doesn't do anything. It just reads the code and makes sure that it doesn't have any syntax error. When you step through a script and you get to the def line of code, it'll go, look, it'll point to it, and then it'll go on. But it's really taking in that definition and keeping it. When you do an assignment statement, it's keeping that value in its memory for you. It's defining the print years for you when you get to that, when your cursor gets to that point. It doesn't do any printing yet, but when you call it, it then will trigger and it will go back up and say, okay, I know where that is, and I'm going to go in here and do whatever it says for me to do inside of here. And that's when it'll print. Here's our function, print years. And if I call the function at this point, let's see what happens. I'll just do this with the debugger so that you can watch the output. So if I call print years, I get an unhandled exception, name error. Name, print years is not defined. And that's because I did just what I said not to do, which is I call the function before I defined it. The call to the function doesn't have to be immediately following the function. Oftentimes, if you have a lot of functions and a lot of code, you'll have the functions near to the top, maybe the imports first, and followed by the functions, followed by other code, and then the calls to the function will come much later. But here we have a simple example, so I'll just put the function near the top and the function call below it. Now, let me try stepping over the code again. Starting the code by stepping over. Step over to line 1, and watch where the cursor goes. It goes from line 1 to line 8. And that's because the function is not executed when it's being defined. When we stepped over line 1, we got the function defined. So now if I say print years, it was a type of print years, it knows that it's a function. And now when I call print years with the parentheses behind it, it will execute it. So let me just try showing you what happens when I try print years without the parentheses. It returns the function itself. So when we want to call the function, even if it doesn't take arguments, we have to use those parentheses. Now let's step inside. Notice I used the step in button this time, and I can now step over, step inside. Stepping in means that we get to see the debugger walk through the function itself. It went from line 1 now to line 4 because lines 2 and 3 are not executable code. When you just have a string defined on a line by itself, it's not executable code. It works as a comment. The reason we're not using the number sign for these comments is just simply because of convention and the convenience of being able to make multi-line comments in the description of the function. This is called the docstring. So now we get to line 4, and if we put years, YRS, in our watch window, we'll see that it's not yet defined, and when we step over this line of code, it's defined with 5 years in it. And if we step over each line of code, it's going to print information out in the interactive window. And now I'm clicking on line 5. I've gone through all of the years, so the execution is going to go back, out, and it's done. I stepped in, and now I'm out, and there's no line of code to continue with. So that's what I mean when I say the first time you get to this line, it completely steps over and jumps down to this line. But when you call the function, you can go inside of it. When you are just defining the function, it just reads all of the code, the name of the function and the code that's inside of it, and stores that in a defined function. One more thing before I leave this example. Now, a lot of our examples use assignment statements when we call the function. So say we think we want to get the years in a variable when we call the print years function. What will happen when we do this? We step over the function definition again, and we can step in to the function and run through, print our years out again. And we get back here, and now do we have the years defined? It doesn't look like it has a value, but it's not saying it's not defined. If we say print the years, we see that it's been set to the built-in constant none.
if you don't return a value in a function with the return keyword, which we'll get to in a moment in the lecture, you'll get the value of none as the return value. So you don't really want to use an assignment statement when you call a function unless you have the function returning something. Now, what's the difference between printing and returning? Well, printing gives you the information in the console or an interactive window. You see the print statements coming out by the script. A return value gives you the ability to do something with the value that is returned. So let's just add the return keyword here and say we want to return the last year. So the last year is something that we can now store. Of course, we'd want to change the name of the function and the description of the function. This is really changing it drastically because it's not just printing years, it's returning a year. If we store that information, then we can use that value to make other calculations. Say we want to know what year would be 10 years later. As a simple example, later 10 equals last year plus 10. And then let me just run this in standard mode because we don't really need to step through this time. And we get, let's just look at the value of later 10. Now, so it happily finished while doing the arithmetic. When you return a value, you can use that value outside of the function. Let's see if we try to use that value without returning. So let's try year plus 10. So you say, why do we need to return it? Why can't we just use that variable that we've defined there, the last value that it has? So we run it again, and we get to line 10, and the variable year is not defined. The name is giving us a name error because year was defined inside of the function, and so it's out of its namespace when you're trying to use it out here. That's the reason you have to use return statements if you want information that was generated inside the function. If you want to get that information outside of the function, you have to use a return statement.
So you can think of a function as a named sequence of code statements that perform a desired operation. So usually you want to have related blocks of code, not different things going on in one function. Other names that have been used for functions are subroutines, procedures, and methods. That's common other names. Subroutines, it's just used differently in different programming language. Methods are specific. In Python, they're specifically associated with objects. And when we go over defining classes, we'll get into what that means. It's a function inside of a class. Use a def keyword, use that colon, use indentation. The name can't start with numbers or contain special characters. It's like a variable, and we like to use lower camel case on our function names. And of course, you mentioned before, you have to define it first, and then you can call it. Now, in this format example, I've got things inside parentheses. So those are your parameters that you want your function to be able to do things. Well, why would you ever want to have parameters? The reason is because things that are inside a function are kind of in their own little separate world. They call it scope. Okay, so things that are outside of the function that you want to use inside the function, you should pass in. That's what we call it, passing it into the function by using arguments. And that then when you call the function, that's when you pass in the arguments. You use whatever values. So let's get into, well, before we do another example, let's go back to that docstring. So that docstring that we had, so it's called docstring. What do you think doc might be short for? Yeah, document or documentation string. So it just is there because it's a great way to be able to quickly find out what your function does. So you can take your function name and say print your function name and the dot underscore underscore doc underscore underscore, and that will print whatever you've said up in that string there. So it's a shortcut for other people or yourself to know what the function does, docstring. So it should be concise. Really, if it's a really obvious function, you just need one line, but you may need multiple lines, and that's why we use the triple quotes. Try to use full sentences and end with a period. They look nice. Write as a command, print every year, not prints every year. Okay. So, and back into the debugger. When we were talking about stepping through, I said, use this middle button. Use the middle button. Don't use the left button because you'll go into some world that is like the built-in Python stuff. Get in there, you just gotta get out of there. But if you have a function that you define, you can step into it and see what's going on there. And that's what you have to do to understand. So if you get to that line of code that says print years and then you click the step in button, then you're going inside of your, you can step, and then you can do the regular step once you're inside of there, and then you can step out. Functions are really about code reuse and code organization. So if you have related chunks of code and you just really want to abstract them out, say you have 10, 15 lines of code that are really all about computing the pollution value for a certain emission factor. Probably your main thing of your code is that you want to get some geographic data out of it in the end. But you may have to call this set of 15 lines of computing the pollution several times because you've got different factors. There's a number that you vary based on which factor you're doing it for. So you don't want to have those 15 lines of code 5, 10 times in your script. Instead, you can have a function which defines those 15 lines of code, and then you just say, compute pollution, and it returns a value for you. And then when you need it again, you say, compute pollution, and it returns a value for you. So it's kind of taking the detail level work and putting it all in one place so that you can reference it more than once, and that it also makes your main code a lot cleaner. Because you're doing something that's really kind of like a little side conversation out what it should be in a side conversation. So it enables you to reduce the amount of repeated code you have, and maybe eventually you decide, okay, I need to write another script that also does the pollution computation, but the rest of it is very different. So then you have that little chunk of code, you can just take it, copy it, reuse it. It's a real organizational thing. Here's an example where the code is doing buffer analysis and clip analysis, and there are some, can you see the common lines of code in both of these two columns? Number 10 on this line is the same as number 7 on this set, and then it kind of goes on. So it's reading the data, creating HTML, writing HTML output, writing layer selection list. So this is a case where maybe you could have this sort of post-processing function that you call in either case, and it takes care of these things. And if you go on, there's a zoom to selection, a set output features to visible. So if you're doing both the buffer and the clip analysis, it might be worthwhile to write a couple of functions that say, like lines 14 through 17 of this pseudocode and lines 11 through 14 of this pseudocode really are just so they're zooming, they're setting the output features to visible, and turning off the non-output features, and then taking a screenshot. So all of those steps are in aid of creating a screenshot of the output. So it could be that you write a capture screenshot function that would take care of the zoom, you pass in the layer name or number that you want to turn on or off, and then you would capture. And that would be a way to make your code nice and tidy and efficient. And then a couple minutes ago, I mentioned that things that are inside of the function and outside of the function are kind of in their own worlds. And we talk about this as scope. If you say x equals 5 out here, as far as you're concerned, you've assigned a value to x. So this is in your regular code. If you say def add proc, and so what does this def add proc statement do? Define a procedure named add proc. And does it take any arguments? Nope, we have empty parentheses here. And then the add proc is supposed to say x equals x plus 1 and then print x. So add 1 to x and then print it. If we then call, that's what this statement's doing, add proc, then we get an unbound local error. Local variable x is referenced before assignment. So if you try to use a variable that's inside of a function and hasn't been assigned a value inside the function, then you're going to get this thing. But so, hey, I want to use a number that I've assigned outside of here. I say I'm getting it from the user, or it's a value that I've calculated. I want to use it inside of my function. I can't just refer to it. So instead, I need to pass it in as an argument. That's when we come into why we want to define functions that have parameters. Just like all of the function of a get count, you have to pass a string in that represents the table that you want to get the count for. Def add proc, and then to put num inside the parentheses, then when we call this procedure, we have to call it with something inside the parentheses. That is a number that we want it, because it's got to be a number because we're adding 1 to it inside of there. Otherwise, it's going to break when we do this. So if we call this with x, x is assigned the value of 5. So it'll go tick, 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 add proc, and then num will be assigned the value of 5. It'll say 5 plus 1 equals num. So it'll be, say, this will become 6, right? And then it prints out the number 6. Okay. So that's how you get things in. Pass it in as a parameter. You need to pass values in as a parameter or an argument. One thing you may have noticed is that I use the variable named x outside of here and the variable named num inside of here, and that was intentional because it's a good idea to use a different variable name for the same thing that's being referred to inside of the function, because it has to do with just confusion, human confusion on which x you're dealing with. I could actually define something in here that has the name x, and will be a different instance of that variable name. Can have a totally independent value. Namespaces, that's an advanced topic that we'll not go into, but if you want to get into advanced Python, that's something that probably you need to learn about, the namespaces. Here's an example of our silly printing years example, but with more sophistication. So in this case, it takes in 2 parameters, right? A start and a stop, and then it uses them inside of the function. So down here, notice that inside the parentheses, what's the term I used for this line of code? I say that we are calling the function. Okay, we're calling the function. Yo, print my messages, calling you. So, right? I mean, that's what it means. We're calling out to it to do its thing. So we're calling it with the values of 1920 and 1926. Those could be any numbers that we decided upon. How comes it prints 1926?
You have the stop plus 1.
Because we did a stop plus 1 in there because we wanted to make our function a little more intuitive. Python gurus know that the range function does up to not including the right side, but it's kind of nice to have a function that does what you expect it to if you say print years 1920 to 1920. So it's 2, 2. given script contains two function definitions, calls these functions as examples. A list of file names is given in the code. Okay, just a hard-coded list. Write code to loop through the test list and print only names that end with SHP. When that is working, put the looping code that you wrote for number 1 inside a function definition. So test your code out before you create the function. Pass a list in as an argument. Write a line of code to call the function using test list. The idea is to replace the code you wrote for number 1 with a function definition. Pause the recording for a moment and let you get here. To work with a function that has a return value, we did a silly example, which just returns a string literal Lily. But if you want to get so we know how to get information into the function, but how do you get information back from the function? Say if you calculate the pollution value, how do you get that information back? Well, you use this keyword return. And whatever has the keyword return on it, it'll do there. One point of confusion is we do a lot of print examples when we're first doing functions. It's the easiest thing we know how to do. Is this return value, if you have it in here, is going to be what it returns. And then you can use an assignment statement for what it gives you back. It gives back, in this case, Lily. So if we run this whole spiel, we're calling the function here on line 44, which prints a.shape because our test list has that value in it. Then we call it again, and it prints a.shape again. And then we print x, which is the return value. So now, if I don't have the keyword return, if I'm not returning anything in the function, and I do the same code, I'm going to get a return value of none. I promise you some of you will do this by mistake when you're trying to do the homework. Because this is what, if you don't define a return value, this is what your function returns. And sometimes you don't want a return value. You just want it to alter the conditions in some other way, and you don't need a value returned from it. Like your butler dims the lights. You don't need to hear back from him again. You know the lights were dimmed. So, and we also played with stepping into this function. So we have some breakpoints set on line 39 and line 40. So I ran to the first breakpoint and I got to the beginning of the function definition. If I step over, it just steps to line 44 because it's just getting that definition of the function. Now, if I step in, I'm going back up to line 39. And I step through there, and it does its thing, which is to loop through the whole list and print out any names that are SHP, end with SHP. And then, once it's done with that, it just goes down to the next line of code that is after the line of code that was called from. And then if I step into this statement, it's going to go back up into that because I'm calling print SHP. And step-a-do. And I come back out, and it's going to print that none because I'm not returning a value. In this example, years is first defined with an assignment statement inside of here, and if I try to print years outside of that function, it's going to give me an undefined, a name error because it's not defined in that scope. So we need to return that value if we want it. Syntax for that return. Return is one of Python's keywords, so it's all lowercase. Return that value. So when it comes back, it automatically gives, if you use an assignment statement, it'll give that value to whatever you've got on the left side of your assignment statement. You call it and use an assignment statement with the variable that you want to hold the return value in on the left side there, if you're returning a value. And usually that return statement is is often the last line in your function, because once you hit the return statement, it doesn't go to the next line. It returns, it jumps right out back to your main code. So this guy returns a value. So what I want to say about this function, this script right here, is that it has script arguments, right? It's taking in a rise and a run from the user, and that the function has arguments. Okay, it's taking in a line rise and a line run. And so make sure when you're thinking about the vocabulary that you differentiate between script arguments and function arguments. Okay, so here we're using that return slope, and we're setting that over here. Anybody see anything wrong with this function the way it's defined right here? Well, like
Cast as a float.
we cast things as floats up here. So those are being passed in as floats. Just a kind of a case that we're not testing for.
Divide 0.
Yeah, zero division can be problematic, right? So we probably would want to make a more sophisticated function than this to check for 0 before doing the division, because that'll throw an error. Okay, so as I was talking to that group earlier, there's a common mistake of printing out the return value for functions that don't return anything, and if you do that, you're going to print the built-in constant none. So if you see that, that's probably what's happening. This function here doesn't have a return value. It just does something inside of it, but it doesn't have that return keyword. So this example is a simplest example that has no arguments for the function, no arguments for the function, and no arguments for the script. This example has arguments for the function. They're hard-coded, though. They're not passed into the script. And this example has both script arguments and function arguments. So just so that, like I said, you want to get that vocabulary clear. So this one, to call it, you'd have to pass in some numerical values. For this one and this one, you wouldn't, when you run it, you wouldn't have to pass anything in because they're hard-coded. But it's kind of stupid because it does the same thing every time. Sort of a useless little script there. Okay, we don't have time for add 5. We'll just go over optional arguments and then we'll split. So optional arguments, in some cases, you may want to allow the user to, well, just like, you know, about the tools, right? They have required and optional arguments. You may want to do the same kind of thing for your own functions. You may want to have some default values that they're set to if the person doesn't pass in arguments. So in order to make a function that has optional arguments, it looks like this. The format looks like this. So still def, still the name of the function, still any required arguments have to come first. But after that, you can have optional arguments that have an equal sign with the value that's the default value. Okay, so this function could be called with 1, 2, 3, 4 arguments, or 1, 2, 3 arguments, or 2 arguments. Okay, and if you call it with 2 arguments, the third argument is going to be set to the default value. And the fourth argument is going to be set to the default value. Okay, and that's how it works. You can't you can't use the you have to pass something in for argument 3 if you want to use argument 4. Okay, because it doesn't know that if you put 3 in that you want this one, and this one. if you want first, second, and fourth, you can't do it like that. It's just silly ordering. So this is one configuration for procedures that they just use the order to understand what you're trying to use. So in this example, we have a required rise and an optional run for this. So we could call find slope with a rise and a run, and then it'll pass those values in and use those. But if we call find slope with rise, what's the run going to be? 4. Yeah. So it'll take whatever value we pass in and divide it by 4. So this example, we passed in 20 and 10. So we do find slope of 20 and 10. It takes 20, divides it by 10, and returns that value. And then we collect that value in slope 1, and then we print that value out. And then we call find slope, and we call it with just the number 20, right? And we pass that in, and what value is that going to return? What value is slope 2 going to have?
5.
5, because it's taking 20 and dividing it by 4. And so then it's printed out down here. Slope 2 is that.
This video discussed the syntax for defining functions and calling them, and for creating functions that take arguments and return values. We also discussed scope, which is the reason that we have to take arguments into functions and return values from functions, because variables that are defined outside of the function may be needed inside of the function, and they may not be directly accessible, and vice versa. Some values, some variables that are defined inside of the function are not available to the script code that is outside of the function. And if you can explore that, as we saw, using the debugger to see when the variables are defined and when they're not. We also differentiated between script arguments that are passed in by the user, those are script arguments, versus function arguments, which are arguments that are passed in by the code where the statement that calls the function is. And optional arguments shows here in the additional topics, although we did talk about how to do that, but that's showing there because we have a few more examples in the remaining slides of optional arguments and using those. There are also some slides on how to return multiple values from a function. In the next topic, we'll learn how to use cursors to read and update the records in GIS files.